So, what if you could build and perfect an entire factory before you even lay a single brick? That might sound like science fiction, but it's actually the reality of the smart factory revolution. And we're about to dive into how it's completely changing the way our world is made.
It really does sound like a riddle, doesn't it? I mean, how can you possibly design, test, and totally perfect an entire production line before anything physical even exists?
Well, the answer comes from completely flipping the script. Instead of building with steel and concrete first, we're now building with data. We're swapping out all that physical trial and error for pure digital precision and prediction.
And look, this isn't just some minor upgrade we're talking about. This is a ground-up, total reinvention of manufacturing, and it's all being driven by the power of digital technology.
All right, Section 1, Beyond the Assembly Line. To really get a handle on this shift, let's put the old way of doing things right next to the new way.
On one hand, you have the traditional factory. Rigid assembly lines, laser focused on one thing, cranking out the exact same product over and over as cheaply as possible. But on the other hand, you have the smart factory, and it's a whole different ballgame. It's all about being agile, allowing for customization, and using a constant stream of real-time data to create this intelligent ecosystem that can change on a dime.
So, at its heart, digital manufacturing is all about using computer systems to model, simulate, and analyze, well, everything. And the incredible advantage here? Engineers can perfect the entire production process, from the factory floor layout to the final product, all inside a virtual world. This saves an insane amount of time and money before a single physical part is ever made.
Okay, Section 2, the digital blueprint. So how exactly do you build this virtual factory? Well, the secret is a concept that honestly feels like it's pulled straight from a sci-fi movie, but it's absolutely revolutionizing industries as we speak. It's called the digital twin. I want you to imagine a perfect, high-fidelity virtual replica of a physical object. Could be a jet engine, a car, or even an entire factory. And this isn't just some static 3D model. It's a living, breathing, dynamic counterpart.
This whole thing is built on 3 pillars. First, you have the physical object itself. Second, you have its digital model. And third, the really crucial part, is what's called the digital thread. Just think of this thread as the nervous system. It's a constant flow of data from sensors that makes sure the digital version is always a perfect, real-time mirror of the physical one.
And this is where the magic really happens. Want to see how a new machine will perform under extreme stress? Or maybe find the absolute most efficient layout for a new assembly line? You can test it all on the digital twin without risking a single dollar on physical equipment or factory downtime. It's a total game changer. All right, Section 3, Code, Lasers, and Layers. So we've got the digital plan all mapped out, but how do we turn all that data, all that code into something you can actually hold in your hand?
Well, there are 2 main paths to bring these digital designs into the real world. The first is additive, which you probably know as 3D printing. It's kind of like building with digital Legos, adding material layer by tiny layer. It's perfect for creating complex, custom shapes. The second path is subtractive, which is more like sculpting. You start with a solid block of material and then carve away everything you don't need to reveal the final part. This is often used for high-strength metal components. Now, the secret sauce that ties both of these methods together is CNC technology. Computerized, numerically controlled machines are basically the translators. They take the super precise instructions from a digital design file and execute them perfectly in the physical world, whether that means adding material or taking it away. Let's move on to Section 4, Promise, Peril, and Payoffs. Now, this all sounds incredibly promising, right? And the benefits are huge, but here's the thing. Connecting everything in a factory also opens up a whole new world of risks. So let's break down the good, the bad, and the bottom line.
First up, the promise. Digitizing operations can boost efficiency by up to 20%. That's a massive gain, right? It lets companies do way more with less waste and less effort. And it gets even better. By digitizing supply chains, companies can slash their operating costs by as much as 30%. That's all thanks to smarter inventory management and logistics. But like I said, there's another side of this coin. And here it is. This is the peril. All of that digital connectivity creates new ways for attackers to get in. A recent report found that a jaw-dropping 1 in 4 manufacturers had to completely shut down their operations in the past year because of a cyber attack. So where are these attacks coming from?
Well, the data tells a pretty clear story. A massive 72% of them originate from the company's own IT systems. The very networks that are connecting everything. It's a huge reminder that as our factories get smarter, their digital defenses have to get a whole lot smarter too.
And the cost of failure is just astronomical. The average data breach costs an industrial manufacturer nearly $5 million. I mean, the stakes really could not be higher.
Okay, so with these huge promises and very real perils in mind, what does the immediate future look like? Let's talk about the key trends that are defining the factory of tomorrow today.
What you're looking at here is the whole shebang. This is the big picture vision of digital manufacturing. And you'll notice it's not a series of separate steps. It's a continuous, integrated information loop. It connects everything from the first spark of a design idea all the way through production, distribution, and even thinks about the product's use and its eventual end of life. So looking ahead to 2026, a few key trends are really taking center stage. We're going to see agentic AI. Think of them as smart assistants for the factory, AI systems that can actually make routine production decisions on their own. Sustainability is going to move from being a checkbox to a core measurement of success. And as we've seen, cybersecurity isn't just an IT problem anymore. It's a top-level strategic priority.
The main takeaway here is pretty clear. This whole shift, it's inevitable. The debate is no longer about if factories will go digital. The real question is how quickly and effectively they can make the change. The technology is officially here, and it's transforming our world at an incredible pace. But this revolution isn't just about machines and software. It's about people. It's about skills. And it's about our readiness to embrace a totally new way of making things. The factory of the future has arrived. The real question is, are we ready for it?